There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromide, lithium, beryllium, and barium. Isn't that interesting?
3, 2,
I hope you're all paying attention. There's going to be a
fire.
short quiz later on.
Okay.
There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Hello, everybody.
Chemical Charlie here.
And I'm Pie Guy Pepin.
All right, now we're going to show you what happens when you heat water in a closed container. So I got water very hot. I'm going to put it
It's boiling.
in a closed container, and I'm going to put a shield on it. As you know, the vapor pressure of water increases with temperature. And the pressure on the outside, of course, is 1 atmosphere. Okay, now the pressure is building up. You have to be careful doing this. We have a container, and maybe we should stand back a little bit.
Yeah.
Maybe move your chair back a little bit. Now, when the temperature reaches 100 degrees in an open container, water will boil. But in a closed container, you're keeping the pressure inside that Erlenmeyer flask is getting higher and higher and higher. And it's putting pressure on that cork, that rubber stopper at the top. Eventually, it's going to burst. Okay?
Don't be too close, and don't do it without this.
Without the shield.
Without the shield, because
Obviously.
if you do it without the shield, then it will pop out and break stuff.
When it goes off, it's going to give off a lot of steam. Maybe we should go into the other room. Okay, now you can hear all the steam coming off. I'm going to pull the
You
plug.
can even see some steam from the back.
And
there's even some water that forms.
yeah, the steam condenses to form water.
Now can you see why you shouldn't do this without the sealed?
Okay, so I think that was a good demonstration of how the vapor pressure of water increases with temperature, and how it can cause a little explosion. Not a chemical explosion, it's a physical change with the water's going from a liquid to a gas inside the container. The pressure builds up and it pushes the rubber stopper off the top. Okay, thank you for your attention.
And we'll see you next time.
Okay, just want to explain a little more about what happened in that following demonstration that we just did, that previous demonstration. Here is a graph of the vapor pressure of water as a function of temperature in degrees Celsius. And this orange line here is 760, which is atmospheric pressure. As you can see, the vapor pressure starts out very low and increases very rapidly as the temperature rises. And of course, it reaches 760 at 100 degrees. So if water were in an open container at 1 atmosphere pressure, it would start to boil at 100 degrees. However, if the container is closed, the pressure will continue to increase without boiling, and increase and increase. And of course, it's very dangerous to do this. One has to be careful. We had good precautions, although we could be accused of being a little reckless. So the temperature increases, the pressure increases, and eventually the pressure gets so great that the rubber stopper exploded off. I have no idea how high the temperature was at the time of the explosion of the rubber stopper out of the Erlenmeyer flask, but it was well above 100 degrees temperature and well above 1 atmosphere pressure. Okay, thank you for your attention, and we'll see you next time.